Okay, so my first problem was problem 39, and it reads, Tom is climbing a 3-meter long ladder that leans against a vertical wall, contacting the wall at 2.5 meters above the ground. His weight is 680 newtons, as a vector pointing directly downward, and his weight is measured in newtons, which is abbreviated with N. What are the components of Tom's weight parallel and perpendicular to the ladder? So as my first drawing, we have here the 3-meter ladder leaning against the vertical wall, contacting it 2.5 meters above the ground. We have Tom's weight vector, which is 680 newtons straight downward due to gravity. And then we have the two components the problem is asking us to find, the vector parallel to the ladder and the vector perpendicular to the ladder. And then we have those same vectors here with the 3-meter ladder leaning against a 2.5 meter wall. And what we need to find the components of the vectors is the angle between the ladder and the wall. And we can use cosine because of the adjacent side and the hypotenuse is given to us. So you can take the inverse cosine of theta, which will get you the 33.56 degrees. And with significant figures, we'll have that as 34 degrees. With that, we can now find the two vectors with the angle. You're going to take the entire weight, the entire vector, which was 680 newtons, and then you'll multiply that by cosine 34 to find your x vector. But since we really don't have an x vector because it's a tilted graph or like tilted vectors, this would have been our x, this would have been our y, showing that you just tilt it slightly, and you'll get these vectors as your new like x and y coordinates. So to find the x, you'll do 680 multiplied by the cosine of 34, which was this angle, to get you 563.75 newtons. And then you take the 680, multiply it by the sine of 34 to get your y, which was 385.25 or 380.25 newtons. And with significant figures, since we only have two with our least significant figures, we have 560 newtons as our force perpendicular to the ladder, and we have 380 newtons as our force parallel to the ladder.